Okay, so on behalf of Collabora TACT, I'd like to welcome all of you to this special seminar on IoT emerging architectures and protocols. Let me introduce Collabora TACT to you first. TACT, which stands for Technology Academy for Competency Training, is an initiative of Collabora to offer state-of-the-art skill development training programs on emerging technologies. Collabora is a $550 million US-based IT staffing firm with 350 plus clients across the globe. We have certified thousands of corporate professionals on various emerging technologies in the past years, and most of the training programs being offered by us are ranked #1 globally. We are holding #1 position for consecutively 2 years in IoT training, as well as TACT has been awarded as for its excellence in training by World HRD Congress in Asia. We are training partner with Google, a registered business partner of IBM, and advantage partner of MEPAR. In today's webinar, I'm going to talk about Internet, the transformation of Internet into Internet of Things, and various challenges being faced by the designer community, as well as we'll talk about the standard architecture and solutions addressing those problems and issues. My name is Shafi Patel, and I'm a senior technical trainer, IoT evangelist, and head of the training arm of TACT. So let us start today's webinar with the introduction of the very well-known technology which has revolutionized human interactions in recent years, the Internet. The Internet is actually a global system of interconnected computer networks that use the standard Internet protocol suite to serve billions of users worldwide. In fact, Internet is a network of networks based on a standard protocol suite. One of the standard architecture the Internet is based upon is the very famous and popular 7-layer OSI model. We have almost entered into a new era, and knowingly or unknowingly, we are a part of a revolution called Internet of Things. This promising technology, which is expected to be 10 times more impactful than internet technology is going to transform the way we live, work, and act. See, so IoT is all about extending the computing and communication capabilities to mundane objects not normally considered as computers. So basically, there is something called cognification. Cognification means embedding intelligence into mundane objects. For example, a shoe or a wristwatch or a washing machine or a car could be connected to internet once we embed 4 essential capabilities into it. These capabilities are sensing, computing, actuation, and communication. Once you embed these capabilities into any object, that object gains potential to be connected to internet as an IoT endpoint. And it is being predicted that by 2020, more than 100 billion devices are going to be connected to internet. There are mainly 3 factors which are responsible to bring IoT to reality. The first factor is ubiquitous presence of internet and connectivity. The second factor is widespread adoption of internet standard IP-based communication. And the third factor which is responsible for this is miniaturization of electronic circuits as well as advances in data storage and analytics. However, there are some critical issues and challenges that need to be addressed to make IoT happen. And these challenges have to be taken into consideration in right manner, have to be addressed in right manner to make IoT happen. So, as I just explained, that IoT is all about embedding those 4 capabilities into mundane objects to enable them to get connected with each other and seamlessly share or exchange data and signals. Objects directly connected to each other using data link layer technologies like Bluetooth and Wi-Fi build networks called machine-to-machine networks. The internet is one of the existing communication infrastructure that could be leveraged to gain connectivity, or let's say gain long distance connectivity between machines or devices. So as you can see here, there is a simple explanation of internet. So as a component of an IoT ecosystem, we have devices It sends and receives data, interacting with the communication infrastructure called network, and network help us in transmission of data or exchange of data between devices. We may have a group of routers and gateways to deploy computing at the edges, and we may have data storage or database hosted at the clouds, right? As well as applications running on the cloud to analyze the collected data from the devices, to extract valuable insights, as well as to generate the triggers to perform physical actions at the device end. And to make all these things happen, to make all the components seamlessly connected to each other, the applications running on the cloud side, the application running on the devices, we need standards. Standards way of communication between all the entities forming a network. See, the current IoT landscape appears as highly fragmented, and we all know that a fragmented implementation environment will certainly inhibit unleashing real potential of IoT. And this is why appropriate standards and reference architectures are required to ensure greater user benefit and realizing full potential of this hyper-connected world of Internet of Things. See, we have diversities at the bottommost layer of IoT, and this diversities at the bottommost layer of this technology, I'm going to say diversity of the devices, the heterogeneity of devices are creating bottlenecks. Friends, a recent McKinsey analysis revealed that by 2025, IoT applications will have an economic benefit of $11.1 trillion, up from 0.9 trillion in 2015. So that is the revelation of the study conducted by McKinsey. Of course, these studies are encouraging since they suggest a tremendous impact of the IoT over the coming year. However, the same study also points out to a significant threat to the estimated economic benefit, and this threat is the missing interoperability between devices. Right? So that is interoperability of the devices is one of the threat. And this is what is acting as a motivation for all of us to standardize the communication processes. An end-to-end IoT ecosystem is primarily an ensemble of three components. These components are IoT endpoints, the network as a communication infrastructure, and cloud platforms. So these are the three primary components of an end-to-end IoT ecosystem. I'm repeating it. The first component is IoT endpoints, and we all know, and most of the research firms have like predicted that by 2020 this IoT endpoints are going to be 100 billion, and this is one of the core objective of this technology IoT. The objective is to build a society of more than 100 billion smart, intelligent, cooperative objects, and connecting these objects to each other to build intelligent environments. Now, one of the examples of a fully autonomous, self-reliant, smart system is a driverless car, and we'll have more than 100 billion such products which are going to be end-to-end autonomous in terms of their functions as well as behavior. And we are going to have smart and intelligent environment. The best example of an intelligent environment is the Amazon Go technology. So Amazon Go technology is a retail revolution wherein they have created an intelligent environment, and this intelligent environment is going to be fully autonomous end-to-end. Now this idea could be extended to other domains too. We can have a home, an automated home with the help of IoT technology converted into an intelligent environment. We can have a building transform into an intelligent environment. We can have a city transform into intelligent environment, and we can have a planet, the entire planet transform into an intelligent environment. And that could be achieved if we solve this issue of interoperability at the right time, at the right moment. Right? So and this is why we need standards. We need the standard to realize the full potential of this technology, IoT, which is going to contribute more than $19 trillion in the global GDP by 2025. Right? So the reference architecture or the standard architectures have to cover all the aspects as well as all the components of end-to-end IoT ecosystem. The cloud or server-side architecture, the networking models, as well as the application agents running on the devices. Right? All these aspects have to be covered by a standard architecture. Right? So let us get into more detail. Let's talk about the hierarchy of interoperability. Why we are looking at, or why we are considering this to be a hierarchical nature problem. The reason is this technology itself, as I said earlier, is an ensemble of many technologies. I guess there is a question from one of the participants, Sayyid Muqsid. Sayyid, we'll have a question answer session at the end, right? So yes, I'm coming to. We'll have a question answer session at the end, right? So that would be the right time to ask question. Okay. Yes, I'm going to talk about heterogeneity of IoT devices in the coming slides, and most of the points are going to be covered, right, in the session itself. So let us wait for this session to end, and then we'll have a dedicated question answer session at the end. Thank you, Said. So friends, I'm talking about the heterogeneity. Yes, heterogeneity makes these IoT devices hardly interoperable, and that is going to be self-explanatory, right? So let us talk about the hierarchical structure of this interoperability issue. The first, we need this interoperability to be gained at various levels or various tiers or layers of an IoT ecosystem. Right? The first interoperability is the technical interoperability, and I think this is the one of the most critical layer. Right? Why? Because this is the bottommost layer of an IoT ecosystem. Right? We need, like, this technical interoperability is defined as an ability to exchange information across systems. Right? These systems could be heterogeneous, right? So an ability to exchange information across systems using a standard communication protocol. Right? So it comes to connectivity technologies, we have wired and wireless options available with us. The wired options are UART, Universal Asynchronous Receiver Transmitter Protocol. USART stands for Universal Synchronous Asynchronous Receiver Transmitter. USB stands for Universal Serial Bus. SPI, it's a 4-wire serial communication standard, stands for Serial Peripheral Interface. I2C, a very popular 2-wire interface, stands for Inter-Integrated Communication. And Controller Area Network, or CAN. Right? So we have this connectivity, wired communication technologies with us to connect devices to each other for seamless exchange of information. Right? When it comes to wireless options, we have various options, and wireless is one of the prevalent way of communication, or let's say one of the prevalent way of connecting devices to each other at present. We have short range, medium range, and long range communication technologies, ranging from NFC to LPWAN technology, for example, LoRa and Sigfox. So we have short range communication technologies like NFC, RFID, Bluetooth, Bluetooth Low Energy. We have medium range communication technologies like Wi-Fi and Zigbee. We have low power wide area network communication technologies like Sigfox and LoRa. And we have all those cellular communication options available with us to connect, to gain, let's say, physical level connectivity between our devices. On top of it, to enable our devices to talk to each other using internet as a communication infrastructure, we require protocol stacks, the internet protocol stack. We have legacy protocol like TCP IP. There are two options at transport layer, TCP as well as UDP. And we have legacy application layer protocol, one of the well-tested, most widely used, HTTP, Hypertext Transfer Protocol, right? But most of these existing web services architectures, like client-server architecture, as well as legacy protocol like HTTP, are being challenged by lightweight, message-oriented protocols and architectures. So we have more IoT-friendly protocols like MQTT, CoAP, MQP, which are replacing HTTP in various IoT implementations, as well as well-tested web services architecture, client-server architecture is being challenged by a more power-efficient and easy-to-implement architecture called publish-subscribe architecture. Right? So lots of things are happening in the communication domain when it comes to IoT. So obviously a wide range of IoT deployment employs a number of different network connectivity technologies. The upper layers in a communication model must handle the diversity of underlying low resource or resource constrained IoT devices and provide a uniform interface between devices from different vendors. Right? So let me repeat it again. See, the high level protocols, like I was talking about MQTT or CoAP or HTTP, should hide the underlying complexities or intricacies or heterogeneity of the devices from the applications running on the top of it. Right? And this is why we need this level of interoperability. Okay. The next level of interoperability is called syntactic interoperability. It is defined as an ability to exchange information using specified data formats. Anyway, see this interoperability or syntactic interoperability is a prerequisite for the next level or next layer interoperability called semantic interoperability. So syntactic interoperability refers to the packaging and transmission mechanism for data. Obviously, to deliver data from one device to other device, it needs to be packed into packets and frames, and we need this to be standardized, right, to gain interoperability at this layer. The next level of operability, which is achieved when interacting systems attribute same meaning to the exchange content. So the problem is the interpretation of exchange data has to be proper, right? And these capabilities need to be developed in the applications running on end systems. So finally, these are the applications running on the communication on top of communication protocols or communication protocol stack to interpret the received data and extract the right meaning out of it, right? So semantic layer interoperability could be achieved, and it all depends on the application running on the both the ends. Okay. Now finally, a higher level of interoperability called conceptual interoperability is to infer the high level meaning from the collected data. In one of the as a reference, I'm referring to one of the research paper published in Ubiquity Symposium. The Internet of Things, the title of the paper was The Internet of Things, a case for interoperable IoT sensor data and metadata formats. It was presented by Milan Milankovic. He presented that the challenge for the community is to devise standards and practices that enable integration of data from sensors across devices, users, and domains to enable new types of applications and services that facilitate much more comprehensive understanding and quantitative insights into the world around us. In one of the slides, I explained that the target or the objective of this technology IoT is to build intelligent environments. Okay? And that goal could be accomplished by embedding intelligence into each and every entity that's part of that environment. Right? So first, we need to embed cognitive abilities or human-like intelligence into devices, and that will enable us to eventually transform an interconnected environment of this cognified objects to build a fully autonomous or intelligent environment, right? And that could be achieved only if we collect more data. The data that may be required, you need to collect more data, more information from the environment, right? So actually in reality, we live in an ocean of data. Each and every object is a source of data, and the more data you collect, you're going to be in a better position to know more about the environment. That could be restricted by only by our ability to analyze the data in, let's say, in time as well as in the right manner, right? So conceptual interoperability is directly related to our analytical capabilities. Obviously, we humans are, we have our limitations when it comes to data acquisition, storage, as well as processing. But computers could do it much better than us. Computer could acquire data at much faster speed. Computer could store more data, and computer could analyze or process this data in almost real time and can leverage the extracted insights to trigger or to make better decisions. Right? So making the devices capable of acquiring and analyzing data in real time would certainly help us in transforming this futuristic dream into reality, and that could be achieved by deploying intelligent algorithms on these devices in the form of application running on them. Right? So most of the applications which are going to run on IoT devices are expected to be capable of analyzing data using advanced machine learning algorithms to extract the right meaning or right logics or insights from the collected data. Right? So again, we need this level of interoperability between devices to gain or to build those intelligent environments or self-aware, context-aware environments, right? Finally, the topmost layer is business process interoperability. And obviously, this is where the need of a common language or vocabulary comes into the picture, right? To make the businesses work together or interoperate, we need a common language as well as a common vocabulary. Most of the business processes are getting automated by IoT, and we all know that this automation of processes is making more and more jobs redundant. See, it is expected that by 2025, almost 50% jobs are going to be redundant in various sectors. See, businesses have been using this wave of automation, and this is not the automation of operational technology. See, IoT is not automation of operational technology. IoT is the higher level automation, right? And this is why IoT is going to automate most of the business processes in coming years. And to gain that level of autonomy, obviously we need a common language, a standard which maintains or gains to gain interoperability across diverse business processes. Okay, so we discuss about this various levels of interoperability, and this could be achieved only through a proper standardization process. Right? So as I said, we need reference architecture. So basically, reference architecture acts as a template to create or to build systems and devices using this template as a standard template. Okay? So most of these factors are pushing us or are forcing us to have reference models and architectures to develop common understanding between various stakeholders for a faster, more focused development. And basically, a reference architecture describes essential building blocks as well as the design choices to deal with conflicting requirements regarding functionalities, performance, deployment, and security. Obviously, the compliance to the IoT reference architecture or standard reference architectures ensures the interoperability of solutions, developed solutions, and allows the formation of new synergies across those diverse domains. Right? So reference architecture is the demand of time to make IoT happen. Right? But the problem is, what if, no, there are many initiatives and there are many organizations working to standardize these processes. But the problem is, what if all this reference architecture being developed by various organizations are not interoperable in themselves? Right? And this is why there has to be a standard process, there has to be a defined roadmap to build a single reference architecture. See, how did the 7-layer OSI model help us in building internet? This 7-layer OSI model or open system interconnect model for network design have been used for years by network engineers to build computer networks, right? It provides the reliability as well as scalability and ease of deployment, right? So we need something like OSI model for the entire end-to-end IoT ecosystem. This desired reference architecture should facilitate plug and play across various vendors or stakeholders. And I think the right way of developing this architecture would be the integration of new as well as old or established or well-tested architectures. This reference architecture should provide a common platform, a common vocabulary, and a common language to gain all the levels of interoperability. Now, which are the aspects or which are the components that should be addressed by a reference architecture? See, as I explained, an end-to-end IoT ecosystem is an ensemble of the four, or let's say, I just included three components. Obviously, business tier is not a technical component, but the device tier, network tier, and cloud tier, these are the three technology components of an IoT ecosystem. The device tier are the IoT endpoints, and as I said earlier, this IoT endpoint, most of the IoT endpoints share a common technical configuration. IoT endpoints are combinations of sensors, computers, actuators, and communication technologies, right? And when it comes to sensors, there are variety of sensors: analog, digital, single-ended, or differential, with variable range of output in terms of voltage or currents. When it comes to computers, we have 8-bit, 16-bit, 32-bit, 64-bit platforms. Again, the selection depends or may vary from implementation to implementation. Actuators are optional component of IoT endpoints or IoT devices. Communication is one of the essential capability of IoT endpoint. And as I mentioned earlier, we have variety of communication technologies, wired as well as wireless. And this, this availability of variety of computing, communication, and sensing technology introduces heterogeneity in the devices. Why devices are heterogeneous? Because at the hardware level itself, we have heterogeneities. We sometimes we have devices embedded with 8-bit computers, whereas you can have a device running on a 32-bit computer, right? You can have a device capturing temperature data using a single-ended analog sensor, or you may have another device capturing the same physical parameter, temperature, using a differential, or let's say a sensor which provides differential output, right? So all these hardware components embedded in the IoT endpoints are the source of heterogeneity, right? The second layer, the second component, as you can see here in the picture, is network tier. Again, I already discussed various protocols helping us, enabling us to connect our devices to each other. We have data link layer technologies, wired as well as wireless. Transport and network layer, we have network layer IPv6 is replacing IPv4, to address more number of devices which are going to be connected to internet. At transport layer, we have TCP as well as UDP. At application layer, we have various types of protocols I already discussed. The cloud tier, as you can see here, that is third tier in an IoT ecosystem, may have various architectures. One of the most popular architecture is, we can have 3 components running on same machine. These components are web server, application server, and database server. Or we can have this 3 component deployed on a single machine. Right? So the overall design of a cloud may vary from implementation to implementation. And at topmost layer, we have business tier, or this is where we may may have different various industry verticals, as well as thousands of use cases of IoT, right? We need a reference architecture which could address all these layers, And it seems almost impossible to have one single reference architecture addressing all the layers or all the tiers uniformly. And this is why current design approaches are more and more dependent on domain-specific architectures, right? So mostly over here at device level, at device tier, the protocols from embedded domain or the standard development practices from embedded system domain help designer in building the right, kind of IoT devices. Over here, the OSI or TCP/IP protocol stack has proved helpful for the designers. Cloud tier has its own reference architecture, business tier has its own reference architecture, and what do we need is an integration of all this old and tested architecture. As I mentioned over here, we need an integration between all this old and tested architecture with the newly innovated and emerging architectures. Right? Okay. Now, primarily, two types of IoT implementations are prevalent. In one type of implementation, the devices are connected directly to server-side cloud, and in this case, the devices need to host the transport and network layer capabilities into them, and that obviously that increases the complexity of devices, as well as it could also result into higher level power consumption, right? So, but that is one of the prevalent implementation strategy wherein devices are directly connected to server-side clouds, right? We have another prevalent architecture, and this architecture leverages an intermediate load called gateway. In gateway-based implementation, the devices could use proprietary communication protocols. And second thing, we can offload most of the computing and computation load to gateway. Right? So gateway could enable the resource constrained network clients, if not capable of managing the load of the transport and network layer protocol stack, right? So in this type of implementation, gateway acts as a server for the local devices, as well as it acts as a client for the external internet-based server called cloud server, right? The primary job of the gateway is to aggregate data coming from IoT endpoints. If needed, analyze the data and send the copy of data for long-term storage to cloud. Right? So both of these are proposed reference architecture by WSO2. We have another proposed reference architecture from Eclipse, which is an open source project. Again, here, all those three components are taken into consideration. The constrained devices or IoT endpoints, gateways and smart devices, as well as IoT cloud platforms. The noticeable point here is that remote management, as well as the software application running on all these three layers are also being taken into account, right? We have another, like these are the members of this Eclipse IoT working group. Siemens, Cisco, Reddit, these are the well-known names. We have another initiative from IoT A or IOTA, wherein hundreds of companies are member of this initiative, wherein a unified architecture is being developed by this group of companies. Right? Industry, as we all know, the industry is considering this wave of automation as fourth industrial revolution, and we do have group of companies. This initiative is being led by German manufacturers, and they've already given a name to this revolution. It is being termed as Industry 4.0. And Industry 4.0, it promises high level of operational efficiencies. Anyway, we have a Industrial Internet Consortium, a group of all these companies, more than 140 companies, again contributing in the development of a reference architecture for industrial internet, which is going to be much larger market compared to consumer IoT market. We have one more consortium, which is called Open Interconnect Consortium. Again, they are also developing a standard, and there are so many standard bodies, and this is going to be another issue, that what if all this reference architecture which are being developed by all these standard bodies are not interoperable with each other, right? So and this is why we need a single initiative which could provide us a single common unified standard architecture. The way OSI helped us in building internet, we need one single architecture, one single reference architecture to make this IoT happen, or to transform this dream of IoT into reality, right? There's one more concept, and this concept is actually it's a reason to have all those IoT endpoint acting as resources, right? So we have a World Wide Web, right? This World Wide Web is a repository of information stored at various servers and accessible from anywhere, right? This new term called Web of Things, WOT, is a term which is being used to describe a network of interconnected real world objects. Each object may have its own local repository or storage of information, and just like World Wide Web, we need a browser to help us in accessing all this distributed source of information in the form of IoT devices accessible. So this world of thing could be a practical reality by building it on top of interoperable architecture. Now, to ensure seamless integration of real-world objects and embedded devices as resources into the current web, obviously, we need a unified reference architecture. Right? So most of the information shared by me with you in this webinar have been taken from these resources which are here on my screen. Okay, so let us conclude the session. See, at the end, as we discuss about an IoT ecosystem, I introduce various components of an IoT ecosystem, issues and advantages of interoperability, as well as reference architectures and standards in this webinar. See, we all know that a well-connected world would certainly bring new opportunities for all the stakeholders, will foster innovation and encourage businesses to provide more value to their customer. And this is the core objective of this technology, IoT or Internet of Things. Right? So friends, now we are open for question answer session. If you can share your question with me either in the the question answers panel in the training tool, or else you can use hand raise option to talk to me directly. So let me take the question from Rajendra first. Yes, Rajendra.
I wanted to know about this Eclipse stack, right? Eclipse protocol stack, which has got the stack for the things that is for the device stack, and then the network stack.
Yes.
As well as the the cloud stack, right? So I wanted to know if I have just like we have a development board like Arduino or Raspberry Pi.
Yes.
If we have, do we have to download this particular stack on our development board to start working
No,
on this
it's not
particular
like that,
stack, or
Rajendra.
how do we go about doing it?
Rajendra, it's clearly visible from the picture here on my screen, right? See, the Arduino or Raspberry Pi, obviously these are the
Hello,
yeah. Could you hear me? Can you hear me, Rajendra?
hello.
Yes, Rajendra, I'm answering your question. Can you hear me? Okay, Rajendra, what I'm trying to explain is that this at the device end, we don't need to implement this other component of the reference architecture. The device end, as we all know that Arduino and Raspberry Pi are being used as prototyping platforms for IoT endpoints, right? So on these prototyping platforms, mostly,
Hello.
yes, Rajendra, can you hear me? Okay, Rajan, I'll get back to you. I don't know why. Okay, let me take question from other participants, and then I'll get back to you. Okay, Rajan? There is a question from Syed Muqsid. Syed Muqsid, I guess you might have received the answer. So you were asking about heterogeneity of the IoT devices, right? So I already answered the question. Okay. There is a question from Rajendra again. We have sensors. However, can we find out they are working all the time? Is there anything like heartbeats? Yes, Rajendra. We can have intelligent algorithms running on the sensor nodes to send pings, or periodic messages to tell us that yes, sensor is okay, and sensors can even send us messages if sensors are faulty, right? So we can have a kind of analytics deployed on the device end, and that device, that analytics or intelligent algorithm capable of analyzing the signal or data coming from sensor could like analyze data and can tell us whether the sensor is capturing and sharing a right set of data or not, right? So that is quite possible. We can have sensor side deployment of analytics to know whether sensor is faulty or not. Yes, Rajendra.
Hello.
Yes, Rajendra. Did you get your answer?
Hello.
Rajendra, I cannot hear you. So let's do one thing. I suggest you to drop your question later, okay, through email. Okay, guys, so, let me conclude the session here itself. Thank you very much for patiently attending this session, and do let us know if you need more information, as well as to know more about our training programs. You can visit our website iot.collabratech.com. We have a group of training program, customized for various roles in the industry. So thank you very much for joining this session, and stay in touch to learn more from Collabratech. We keep organizing these webinars at periodic intervals. Okay. Thank you very much. Have a nice day and good night.